let's see if I can win the competition of in a category how many times your demo can fail per day. OK. Who here is using Docker? What are you using it for? Kidding. OK, so Kubernetes? Not a single hand. Oh, wow. Google guys will be disappointed. All right, but you kind of know what it is? Or OK, let me explain that. So, but it's good that you know Docker. For those of you, it's a container. It's kind of virtual, who don't know. It's a container. It's kind of virtual machine, but smaller. And it's if you don't know Docker by now, it means you probably don't know internet exists, because it's all over the place. Anyway, let's make this work. Hey, here we go. So what I'm going to be doing today is another demo, and I'm going to be using heavily a command line to communicate with this cluster and the fake cloud that I'm going to have. To have a fake cloud, I'm going to be using Vagrant virtual machines, and I also have some files on my machine that I'm going to use to provision those, I mean, like the binary ones. The reason I'm telling you all this is you're going to see a link later on where all this is available on GitHub, and you can go ahead and try it on your own. And you're just going to need to have pretty much the same setup to try it out. So before we start doing this cloud thing and start jumping containers left and right, we need an infrastructure. And in a real-world environment, you probably would go with something like Amazon or something like Google or bare metal, whatever that is. And it's going to be a little bit different than what I'm going to show you today because of your infrastructure being a little bit different. But for the purpose of this demo, this is what I'm going to have. I'm going to have 4 virtual machines. And the number one is called, well, actually, I'm going to have 5 of those because the worker thing is 2 of those. And Vagrant was going to start them and provision them, like basically provision the OS. 3 of those will have, 4 of those actually will have CoreOS installed. Anyone familiar with CoreOS? All right, just a couple of people. So CoreOS is an operating system that has aimed to support natively containers. Their package management system is using containers instead of any other packages. So perfectly OK for what we need to do. And the one thing with this guy, which I'm calling outsider here, is to simulate my external infrastructure. All right, so this is basically things that in a real-world scenario you would have somewhere provided by someone and you wire to. So what you have there, I have a MySQL. If you go on Amazon, you're going to be probably using whatever Amazon provides for you in terms of database. Google will be something else. I'm also have an NFS server on this one. And again, in a real-world scenario, you will be probably mounting a virtual volumes or whatever your use case is. Finally, I have a Docker here. And the reason I have a Docker is because I need to run a Docker registry. And this is basically my private registry where all my Docker images will be going into. Now, technically, you don't really need that. If everything you do is public, you can just put it somewhere on the internet and use it. But presumably, most of the time, you don't want all your code to be available to everyone out there. So you're going to have a registry where you put your containers. And again, if you're using Amazon or Google or anything else, they're probably going to provide you with their own Docker registry, so you don't have to do this. So those are the outsiders. How I provision that, actually, I can show you with the code. So my provisioning is very simple. It's just a shell script that installs a bunch of things. I install NFS, MySQL, and I start the Docker registry. Nothing fancy here. And you don't really need to understand that because it's, again, if you use it, it's going to be something different. Now, what's more interesting is the thing called manager. So now this node or this machine is going to have a etcd on it, etcd cluster. And the reason I'm calling cluster is because in a real-world scenario, you will probably need more than one. At least 3 or any odd number, so you make sure your cluster is actually have a proper failover and so forth. Anyone who's familiar with etcd? All right, a couple of people. So etcd is a key values, distributed key value store. So basically, it runs like in a cluster, and you put things under certain keys, and they just work. I mean, in terms of you can get them from any machine. OK, so the next thing I have here is Flannel. And Flannel is provided out of the box with CoreOS. And it's a solution for so-called software-defined network. So essentially, it allows you to define a virtual network, virtual IP addresses, and then assign those IP addresses to different things. And that's what Kubernetes is going to be using later on to actually provide you with IP addresses that are going to reflect your containers, or in case of the Kubernetes, so-called pods. The next thing is Fleet. Fleet is another kind of tool that CoreOS provides. It is basically a distributed manager of services. So if you're familiar with Linux System V or System 5, depends on how you want to call it. Now, there is a new version of it called System D. And System D is basically what's bootstrapping services on your Linux machine. And Fleet is making it distributed. So you can say, start me this service on this machine, or whatever. So before we go, let me quickly show you. Oh, and by the way, for provisioning those guys, I'm using a thing called Cloud Init. And Cloud Init is just a YAML script that when machine boots, it reads this script and figures out what it needs to do. So for the manager here, I have a etcd configuration. Then I have a Flannel configuration, Fleet configuration, and then I'm telling it to start a bunch of things. You can examine that deeper. But what is important in this particular case is the metadata that I pass to Fleet. And basically, that's a label that Fleet is going to use. I'm sorry, wrong key. Fleet is going to use to label my machine. So every time a machine with this configuration starts, is going to be labeled to be in the role of a manager. Another thing that I'm starting here is a tool called confd. And confd is basically a configuration tool that uses any key value store as a backend, reads configuration from there, and based on templates, creates files somewhere. So I'll show you real quick the configuration of confd here. So basically, I'm saying here, monitor key value store, etcd in this particular case, for those keys. And if they change, create me a file, etcd hosts, with this template. And this template is here. So essentially, what I'm doing in here is I'm making sure that I can actually access one server from another based on some keys that I have in the distributed key value store. That's pretty much everything I need to do for the manager. Now I go for the worker. And worker is pretty much the same case. Actually, I can show you the file. It's, again, provisioned by a Cloud Init. It looks pretty much the same. The difference is it attaches a different label. So this machine, or any other, in fact, both of these machines will have this label worker. So you'll see how we use that later on. OK, so now because this is my worker, this is where my images is going to be running. I need, obviously, Docker there. So I'm installing also Docker, installing also NFS client there, so I can have shared things. And that is all in this file. In here, I have confd again. There's a Docker service. And there is a file, where is it? NFS somewhere here. Shared mount, pretty much the same thing. Finally, I need a node to face the outside world, because all this is fine, but it's my internal infrastructure, and I don't want random people to walk around it. So this is the guy that's going to face the outside world and actually allow people to do some stuff. And because it needs to talk to the internal infrastructure, we need all the same setup in there. But obviously, we're going to label it differently. And that's pretty much what I have in terms of infrastructure. Now, here the fun part comes. Now we need to deal with containers, but we don't just want to install manually containers, because it's no point. We want something to manage and orchestrate those containers. And the most popular tool these days, apparently, is Kubernetes, which is a tool from Google. So let's install Kubernetes. Now, you can install Kubernetes in many different ways. The way I choose to do it is I choose to use Fleet for that. So I'm using the Fleet to tell where to install what. And I'll show you that in a second, but let's go through the slides first. So Kubernetes comes in 5 parts. One thing is the API server, which is going to go over there. And the API server is kind of the central thing that everyone is talking to. Then you also have this thing called controller manager. This is kind of the thing that does the work of putting containers here and there. Then you have the scheduler, and the scheduler is a little bit it's kind of hard to get to know which one is doing what, but basically it's scheduling nodes on different containers on different nodes. So these 3 guys need to be together, or at least they need to know about each other. Now, the place where we're going to actually run containers, we need so-called kubelet. And kubelet is basically the thing that's going to get the information from the API, and the API is going to tell him, you need to run this container or this pod in this machine, and it's going to run it for you. And finally, one of the most important pieces is the proxy. The proxy is what makes the networking works. It actually allows you to link into from one container to another and see them as the actual devices. It's doing all kinds of crazy things underneath, like IP table stuff and so forth. Without that, it's basically everything is in place, but nothing sees anything else. And we need the proxy to be everywhere in the servers that we communicate to, so they can actually see each other. So how I'm going to do this? I have these things called fleet units here, and there's a bunch of configuration files. This one, this is the API server. Don't have to read all this, but what is important here is it's basically, you can think of it as a Linux service, what you would normally put in etcd initd. Right? That's the exact same thing. It's just the newest version. It uses systemd instead. What is important in terms of fleet is this last section. It tells fleet on which machine to put it. So what I'm saying to fleet is I want to put this thing on any machine that has the role of manager. And because I only have one machine, that's pretty obvious where it's going to go. Now, the same thing goes with the scheduler. The difference here is I'm also telling Fleet that I not only want this to be on a machine called manager, but I also want it to be on the exact same machine where our API server is installed. The reason I want to do this is because I just want to use local addresses here, and I don't want to deal with all the networking. And basically, the same thing is with the controller manager. Now, kubelet is a little bit different because we want it to be on a worker machine, but we don't want it to be on just one worker machine, but instead we say it's global. So basically, if there is a worker machine, kubelet is going to start there, which means if tomorrow I start a 3rd node with a role worker, kubelet is going to be automatically installed there. And the same thing goes for the proxy, which is also, it goes on the front end as well. It's basically the same thing. So let me now install those guys. Let me show you first. So there is a bunch of tools that you can use locally to connect there. One of them is fleet control. And you can say list machines. And it's going to tell you what machines you have in your cluster. So those are my machines. I have 2 workers, 1 manager, and 1 front end. The outsider is not part of the CoreOS cluster, so that's why you don't see it here. I can also say fleet control list units. And you'll see I have no units running right now. So let's install some units. So I'll call start, and my fleet units, Kubernetes, install everything that's there. And what is essentially this doing is it's going to talk to the cluster and to install some things over there, in this particular case, Kubernetes. So if I do list units again, now I see I have a bunch of units running. And API server, controller manager, and scheduler are both on all the same machine. I have 3 proxies running on 3 different machines and 2 kubelets running on 2 different machines. OK, that's cool. I have Kubernetes up and running. What else I can do? Well, I need to distribute this load somehow, so I need HA proxy. So let me quickly go and install HA Proxy, which is going to be, but before, that's a little bit more complicated, because first I need to put the container in my private repo. And I'm running out of time. I need to really rush with this one. OK, so it's going to take a second for the container to go to the private repo. Please be nice and do this quickly. OK, and meanwhile, I'll show you another thing that that is the fleet unit for HA Proxy. So it's essentially the same thing that I just say, I want it global, and I want it on anything that is a front end. So even if I switch my front end in the future to another node, that's still gonna get me this working. So let me quickly install this. Start fleet units HA Proxy. Here we go. List units. Hey, I have HA Proxy running. OK, so what we do next? Well, that was basically infrastructure provisioning. So now we have all the things in place to actually start dealing with some containers. So that is the moment that everyone's going to tell you that you forget about physical infrastructure and start dealing with a virtual thing. OK, that's not exactly the truth. I mean, the word forget, it's not exactly the truth, but basically that is the concept. So now you have a bunch of things that need to talk to each other, and I'm going to be managing them all from my machine. First thing I need is obviously a Docker container with Liferay. Where do I get this one from? Well, I did create one for you. If you're reading Liferay blogs, you may recall I blogged some time ago about a tool called Liferay CDL that is just one liner that starts Liferay from a Docker container. And so I have a bunch of containers already up there, but that is a standalone container. It just starts one Liferay. And we need something more advanced that is a cluster. So there is another container called Liferay Cloud. And Liferay Cloud is basically an extension of this previous one, with a little difference. It has confd running inside the container. And confd inside the Liferay container is going to be configured to look at the backend, which is going to be the etcd key value store, get all the properties from there, and actually populate the Liferay properties. So if you look into, for example, bundle properties that I have inside the container, those are basically gathered from whatever I have in the etcd store. So I need to push this container to my repo. And this is called Liferay Cloud. And it's version 6.2 GA4. OK, this is going to also take a second to deploy. So essentially, what I'm doing here is OK, I was supposed to do that later. But anyway, let me go with in the meantime, with another description. So now the configuration. We said the configuration is going to be in etcd. So where is that? So if you look into the bin folder here, I have a script, which is called config Liferay demo. It's basically using etcd control. That's another tool that communicates with the etcd cluster and sets a key with a given value. And I do this a number of times. So basically, things that I would normally put in my portal properties, I'm now put it in a distributed key value store. So every container is capable of getting them from there. This is still pushing. The next thing is I need to configure my proxy server. And I'm doing the exact same thing there. This is configuring my proxy. It's essentially putting all this as a configuration into my etcd, and the HA proxy is going to get it from there. Now, Kubernetes starts so-called pods. And pod is a group of containers that work together. Right? So we don't have too much containers to work together. It's basically Liferay, and there is always another container that comes from Kubernetes itself. So we need these pods to work. And we can just start a pod. Now, the problem with the pod is anyone can, with a permission, can log in or issue a comment and say, delete me this pod. And so there is a notion of replication controller. And replication controller is basically monitoring something, pods based on labels, and can create and delete those as needed. Now, you can think of, OK, so I'm just going to create one replication controller, and then I start with 15 Liferays. And that's not exactly the case with Liferay, because the load balancing thing in services and Kubernetes is not so cool on sessions, but that's why we have a two replication controller for the two instances. And then finally, we also have things called services. And services are basically providing a virtual IPs that are static. So you have a static IP that is virtually distributed to some container. So even if this container changes place, which means it changes IP addresses, our IP address will not change. We're still going to be using the service IP address. So let's see how that works. Oh, wait, what I did? OK, here we were. So now, I already pushed this container there. So the next thing I need to do is push my Liferay configuration. So let's do that. Then config Liferay. The next thing I need to do is start the replication controller. So now I have this tool called kube control. And I can say get nodes. Yeah, you need to spell it right. And this is what Kubernetes sees. It only sees things that Kubernetes installed. I can say get pods. You see I don't have any. Replication controllers don't have any. Services, there is one service, always the Kubernetes itself. OK, so now kube control, create from file, kube resources, replication controllers, Liferay demo 1. I'm sorry I'm not showing you the files now, but I really have only 6 minutes, and I want to show you the demo working. So now if I, again, do get replication controllers, now I have a replication controller. And if I say get pod, now you can see I have a pod in here. I can do Kubernetes describe pod, and it's going to give me some information about what's going on with this pod. You see that it created some stuff. Let's see if it created the container. Yeah, here we go. So now I can say kube control logs -f. Where is my? Here is the name of the pod. And I can, from my machine, don't have to log in there. I can actually see the logs, and I can see Liferay starting. In a container, in some place, I don't even know. Well, I can check, but right now I don't know exactly where it is running. So what happened here is this. We created a replication controller, which created a pod, and put a get from the registry a container and put it inside the pod, then confd kicked from inside that container, get the information, the configuration for Liferay from etcd, and started Liferay. Now, what also happened, and we didn't see it, is Proxy created an IP address and hooked it to that particular pod. Then next thing you could do is start, and that it's going to always work regardless of whether this pod goes to some other place or no. So next thing to do is to start a service. So let me create a service, Liferay demo 1 and Liferay demo 2. Just I'm going to create both of them. So let me make it visible for you. So kube control get services. Now I have two services, but if I get endpoints, you will see that one of my services is already hooked to a pod because I already have one replication controller running, and the other one is not. The reason is I still haven't deployed the next replication controller. So what happened here is we deployed a service which essentially created a static IP address that is dynamically resolving to our dynamic IP address that goes to the container. OK. So let me now deploy my proxy configuration, which is going to be in bin config HA proxy. OK. And what happened here is we deploy the configuration, and the confd listening on the HA proxy node is going to get this configuration, configure the load balancer with the static IP addresses that I already know, and do the routing. So now my customers can hit the load balancer, which is going to send them to the appropriate static IP that's going to go dynamic, that's going to go to the container, and eventually Liferay is going to respond. Now, that's all theory. Let's see. First of all, let's see if Liferay is running already. Hopefully it is. And OK, here we go. OK, so now I'm connected. My HA proxy also has a nice admin interface. So it basically tells me what I have there. I have an endpoint, a front end, and then I can either load balancer between the two nodes, or I can just go to one of those. And I already have configured some domain names for this. So this is going to be one Liferay Cloud, and I should get Liferay working from inside the Docker container eventually. And you will probably see, so you can see here requests are 000. I have no request. This is where I'm hitting here, Liferay 1. So if I reload this page, you should see that, in fact, I am hitting it. And hopefully, at some point in time, I'm going to get a response. I have 2 minutes, so let me quickly start the second. That's not this machine. So kube control, create from file, kube resources, replication controllers, Liferay demo 2. So now I'm basically starting another replication controller. It's going to start another pod with another Docker, which is another Liferay in it. So eventually, I should have both of them running. Hey, I have Liferay. Cool. So at least one demo worked. All right. So oops, come back. If I try to access directly the other node, it's not going to work. It's still starting. But if I hit my load balancer here, Liferay Cloud. Now, don't put W in front of it. That's what I want. OK. I don't know why it's not working. I think it's Mozilla. But basically, this should hit a load balancer here. OK, let me show you. So it should hit here and use HA proxy load balancing to actually distribute calls between these two guys. But yeah, for some reason, it's not working here yet. Two Liferay Cloud, still not started. Anyway, 7 seconds. So that's basically everything I have today for you, and at least it worked. So now the only thing I would say as a final note, you saw it in action, you saw it works, which doesn't really mean it's something that you should go and do tomorrow in your production environment. Kubernetes, Docker, all this stuff is really cool from a high level, but unless you're really willing to dig deeper into network layer 3, proxies, masquerading, and all these things, well, in other words, if you want to use this, you better understand those things, because you will end up having problems there sooner or later. Thank you.
Thanks, Milen.